Tonight, the ocean is very calm off the coast of San Diego. It often is, in the early morning hours. The water moves in long, slow swells. The horizon is a soft line between the gray of the sea and the lightning gray of the sky. There are ships out there. There are people on those ships, watching a specific patch of water, waiting. And then something appears. It comes from above. At first, it is a streak of light, the kind of thing you might mistake, for just a moment, for a very bright falling star. But it is not falling the way stars fall. It is slowing. 3 enormous parachutes open against the sky, white and billowing, and beneath them hangs a small capsule, bell-shaped, scorched, moving through the last few hundred feet of a journey that covered nearly 700,000 miles. It settles into the Pacific Ocean on the morning of April 10, 2026. Inside that capsule are 4 people. They have just come back from the moon, not from the surface. They did not land, but they traveled to the moon's neighborhood, closer than any human beings have been in 54 years, and they swung around its far side, and they broke records that had stood for more than half a century, and they looked out their windows at a world most humans will never see with their own eyes. They floated in a space the size of a large camper van, 250,000 miles from everyone they had ever known, in a silence so complete, it has no real equivalent in human experience. And then they came home. You might have heard about this mission in passing. A headline, perhaps. A clip of the launch. The word historic used, as it often is, to describe something that is easier to acknowledge than to actually feel. This is an invitation to feel it, not the urgency of it, not the drama of it. There is no drama here, not in the way that word usually means. There is only the slow, patient wonder of what it means for human beings to travel that far, to pass behind a world that is not their own, to float in the deep dark for 10 days, and to return. That is what we are going to explore tonight, together, slowly. We will begin at the beginning, not with this mission, but with the long silence before it. 54 years of waiting. What filled that time? What it meant that no human being left Earth's neighborhood for so long. And then we will meet the 4 people who ended that silence, and we will learn who they are, not just as astronauts, but as people. We will travel with them, step by step, from the moment the engines fired to the moment the parachutes opened. We will pass behind the moon together, in the quiet. We will watch the Earth disappear below a lunar horizon. We will understand what it means to trust gravity the way you might trust a dear and patient friend. And at the end, we will rest. There is no hurry. The moon waited 54 years for humans to return. We can take our time. If you have just found this channel, you are very welcome here. This is the Quiet Laboratory, and this is what we do. We take long, slow, peaceful journeys through science together. If you are comfortable tonight, settled in, the lights low, the world outside going quiet, you might feel like leaving a comment to let us know where you are. It is always a gentle thing. Knowing that someone else is out there under the same sky, curious about the same things. Now, let us begin with silence. Not the silence behind the moon. We will come to that. A different kind of silence. The silence that stretched across 54 years of human history. A silence that became so ordinary, so unremarkable, that most people stopped noticing it was there. The last time a human being traveled to the moon's vicinity before Artemis 2, the year was 1972. Think about what that means. Really think about it slowly. In December of that year, a man named Gene Cernan climbed into a small spacecraft on the surface of the moon and prepared to leave. He was the commander of Apollo 17. He had spent 3 days on the lunar surface, and before he lifted his boot and stepped back into the lunar module for the last time, he paused. He looked around at the gray, still, ancient landscape. He had a moment, the kind of moment that does not arrive often, and that you recognize only when it is already happening. He said, "We leave as we came, and God willing, as we shall return." Then he climbed in. The hatch closed, the ascent engine fired, and the last human beings to visit the moon left it behind. That was December 14th, 1972. What followed was not a planned absence. No one announced that the human species was finished with the moon, at least not for 54 years. No one made that decision cleanly. It happened gradually, the way many things happen, through budget pressures and shifting priorities, and the slow accumulation of other urgencies. The Apollo program was expensive, and it had achieved its primary goal, which was political as much as scientific. The Cold War was thawing. The race that had driven so much was winding down. And so the moon waited. What is remarkable, quietly remarkable, in the way that takes a moment to settle, is what happened on Earth during those 54 years. The people who designed the Apollo missions, who built the Saturn V rockets, who wrote the guidance software and calculated the trajectories and trained the astronauts, many of them were alive in 1972, working, still young. By the time Artemis II launched in 2026, most had retired. Some had died. The human beings who held the deepest institutional knowledge of how to send people to the moon were no longer available to simply be asked. Children were born in 1972 who grew up, had children of their own, watched those children grow up and have children. An entire generation, 2 generations, came into the world and lived their whole lives in a period when no human being traveled beyond Earth's immediate neighborhood. It was not a crisis. It was simply the condition of things, the default setting of human existence, quietly accepted. If you were born after 1972, which means if you are almost certainly alive right now, you have never shared the Earth with a human being who had traveled to the moon's vicinity. Not until this April. The technology around you changed beyond recognition in those 54 years. The internet did not exist when Gene Cernan left the moon. Smartphones did not exist. The human genome had not been mapped. Scientists had not yet detected gravitational waves, had not yet confirmed the existence of a black hole by direct imaging, had not launched the James Webb Space Telescope to peer into the earliest light of the universe. All of that happened in the long interval between the last Apollo mission and the first crewed Artemis mission. And yet here is the quiet paradox at the heart of this story. When 4 human beings finally went back, they went in a capsule, launched on a rocket, guided by mathematics and physics that would have been familiar, at their core, to the engineers of 1969. The technology was newer, the computers faster, the materials more refined, but the essential shape of the thing was the same. A human body, inside a sealed environment, carried by controlled explosions through the vacuum of space to a destination 250,000 miles away. Some journeys do not change in their fundamentals, only in their readiness. The Artemis program, named for the Greek goddess of the moon, twin sister of Apollo, was announced in 2017. The goal was clear: return humans to the moon, and this time, stay. Not just to visit, but to establish a presence, to learn how to live and work on another world, to prepare eventually for the much longer journey to Mars. The first step was to build new hardware from the ground up, a new rocket, a new capsule, both designed for deep space, not just low Earth orbit where the International Space Station circles in its comparatively close neighborhood, roughly 250 miles above the surface. In November of 2022, that new hardware flew for the first time. Artemis I was an uncrewed test, an empty Orion capsule launched on the new Space Launch System rocket, then sent around the moon and back without any human beings aboard. It worked. Every major system performed. The capsule traveled to the moon, swung around it, came home, and splashed down in the Pacific. The rehearsal was complete. It took another 3.5 years of preparation, testing, refinement, and one additional delay before 4 human beings climbed into the same capsule and made the journey themselves. They launched on April 1st, 2026, April Fool's Day. NASA was aware of the coincidence, and they embraced it with characteristic warmth. The best April Fool's prank, someone noted, was launching humans to the moon. It is difficult to argue with that. Now we come to the four people themselves. Before we talk about their records, and there are records, remarkable ones, it helps to simply sit with who they are. Not as symbols or statistics, but as people. Because one of the quieter truths about Artemis 2 is that all the most extraordinary facts about it are also, at their heart, human facts. The numbers point back to people. Reed Wiseman was the commander. He is an American, a former Navy test pilot, a person who had previously lived aboard the International Space Station and who brought to this mission a quiet, steady kind of leadership. He was 50 years old at the time of the flight, which made him, in a fact we will return to, the oldest human being ever to travel beyond low Earth orbit. He had lost his wife, Carroll, before the mission. He carried her with him. Victor Glover was the pilot. Also American, also a Navy pilot, a person of deep thoughtfulness and precise skill. Yet during the mission, during the most extraordinary hours of it, floating 250,000 miles from Earth, he would share a message on Easter Sunday that reached millions of people watching from the planet below. We will come to that message in its proper moment, because it deserves the space to land fully. Christina Koch was one of the two mission specialists, American, a scientist and engineer who had already spent 328 days continuously aboard the International Space Station, a record at the time for a woman. She had been to space before and knew what it cost, and went again anyway. Something would break on this mission, something mundane and inconvenient, in the middle of a journey to the edge of human experience. Her response to it was so perfectly calm and so quietly profound that we will come to that as well. Jeremy Hansen was the fourth member of the crew, Canadian, a mission specialist. And here is the fact about Jeremy Hansen that, once you know it, sits with you. This was his first spaceflight, not his first trip to the moon, his first trip anywhere beyond Earth's atmosphere. He had never been to space before Artemis 2. There was no gradual introduction, no preliminary trip to the International Space Station, no chance to acclimate to microgravity and relative safety, 250 miles up. His first journey to space was a journey to the moon's neighborhood. His first hours in microgravity were hours spent traveling away from Earth at 17,000 miles per hour. He went from 0 miles above Earth to 252,000 miles from Earth on his first day. You might pause on that for a moment. The nerve required, the training, yes, years of meticulous preparation, but also the willingness to take that as your first step. Most people, learning to swim, begin in shallow water. Before launch, the four of them chose a name for their Orion capsule. This is a tradition. Spacecraft carry names, the way ships always have. They chose together. The word they arrived at was integrity. It is worth holding that word for a moment. Integrity. Not triumph, not ambition, not speed. Integrity. The quality of being whole, of being exactly what you claim to be, of holding together under pressure. It was a word that said something about how they understood the mission they were undertaking. The quarantine had begun on March 18th, 14 days before launch. This is standard procedure for crews before a major mission. You cannot risk carrying an illness into space, where there are no hospitals and no colleagues to cover your responsibilities if you are unwell. So the four of them entered a kind of preparatory isolation. They lived in a controlled environment, separated from ordinary life, for 2 weeks before they ever boarded the rocket. Which means the journey, in a sense, began quietly, without fanfare, 2 weeks early. The world did not notice. There was no countdown clock for the quarantine. But something was already beginning. During that period, the crew received a private screening of a film, a science fiction story called Project Hail Mary, about a lone astronaut far from home and working against vast odds to do something that matters. It is not difficult to understand why that particular story might have appealed to them in that particular moment. There is a small detail from the weeks before launch that carries its own kind of wonder. NASA held a competition to design the zero-gravity indicator for the mission. A zero-gravity indicator is a small object, released inside the capsule at the moment microgravity is reached. It floats free. It is both a practical signal, confirming that the crew is in weightlessness, and a tradition. Previous missions have used toys, stuffed animals, small meaningful objects. This time, NASA opened the competition to the public. More than 2,600 submissions arrived, from over 50 countries. The winning design came from an 8-year-old boy named Lucas Ye. I'm from Mountain View, California. His design depicted the moon wearing the Earth as a baseball cap, a direct reference to the Earthrise photograph, that famous image from Apollo 8, in which Earth appears to rise above the lunar horizon. The mascot was named Rise. Rise traveled 252,000 miles from Earth on its first journey, an 8-year-old boy's imagination floating in deep space. That is what this mission carried with it. Records and firsts, yes, but also a child's drawing of the moon wearing the world like a hat. Now the 4 records, because they belong together, and because understanding them changes the texture of the mission. Victor Glover became, during Artemis 2, the first person of color to travel to the moon's vicinity. Christina Koch became the first woman to travel to the moon's vicinity. Jeremy Hansen became the first non-American to fly beyond Earth orbit, and Reed Wiseman, at 50, became the oldest human being to travel beyond low Earth orbit. 4 firsts on a single mission simultaneously. It is worth sitting with what those firsts mean, not as triumphs to be celebrated loudly, but as the quiet closing of doors that should have been opened much earlier, and the equally quiet opening of new ones. Each of those firsts represents a path that has now been walked. No one will ever again be the first woman to travel to the moon's vicinity. Christina Koch has walked that path. No one will ever again be the first person of color to make that journey. Victor Glover has walked that path. The doors are open now. What comes after can simply be people going through them. That is what firsts do, at their best. They are not trophies. They are permissions granted to everyone who follows. If this kind of slow, careful exploration of the world feels like something worth returning to, a subscription to this channel costs nothing and means that more evenings like this one will find their way to you. There is no hurry and no obligation, only an open door. Let us go to the morning of April 1st, 2026. Kennedy Space Center, Florida. The Atlantic coast, flat and wide. The kind of landscape where you can see weather coming from a long way off. The sky in the hours before a launch has a particular quality, something watchful about it, as if the atmosphere itself is aware that something unusual is about to happen. The Space Launch System rocket stands on the launch pad at 322 feet tall. 322 feet. The Statue of Liberty, for reference, stands at 305. The SLS is taller. It is not the largest rocket ever built. That distinction belongs, at this writing, to rockets that have come since the Apollo era. But it is among the most powerful. At liftoff, it generates 8.8 million pounds of thrust. The original Saturn V, the rocket that carried Apollo astronauts to the moon, generated 7.6 million pounds of thrust. The SLS exceeds it by 15%. There is something quietly moving about the engines that power the SLS. They are called RS-25 engines, and 4 of them are mounted at the base of the core stage. These engines are not new designs. They are direct descendants, refined and improved, but direct descendants, of the Space Shuttle main engines. The same basic engine design flew the Space Shuttle for 30 years. Now it flies toward the moon. There is a continuity there that is easy to miss. The engineers who worked on the shuttle engines contributed, through their work, to the engines that carry human beings back toward the moon. The knowledge accumulated over decades of spaceflight does not disappear. It accumulates quietly, the way sediment accumulates, layer by layer, until it becomes something solid enough to build on. At 6:35 in the evening Eastern Time, the engines ignited. 8.8 million pounds of thrust. The rocket begins to move. Slowly at first, impossibly slowly for something that is, within minutes, going to be traveling faster than almost anything the human world produces. It clears the tower. It accelerates. Inside the capsule, and the 4 crew members feel the force of it. Gravity multiplied, pressing them into their seats, the world vibrating around them. In approximately 8 minutes, they are traveling at 17,500 miles per hour. 8 minutes. 0 to 17,500 miles per hour in 8 minutes. For context, because context is what makes numbers real, a commercial airliner travels at roughly 570 miles per hour at cruising altitude. The crew of Artemis 2 reached 30 times that speed before their first cup of space, before the first meal of their journey was even being considered. The main core stage of the rocket separated and fell back toward the Pacific Ocean. The interim cryogenic propulsion stage, the upper stage, took over, carrying Orion into a highly elliptical orbit around Earth. At its highest point, this orbit reached approximately 1,400 miles above the surface. The International Space Station, where human beings have lived continuously for more than 20 years, orbits at roughly 250 miles above Earth. The Artemis 2 crew, in their first hours in space, were already nearly 6 times higher. Rise floated free in the capsule, the mascot untethered, drifting gently in the microgravity of deep space, or near deep space, for now. An 8-year-old boy's design, doing exactly what it was made to do. A small, quiet signal that the world of weight had been left behind. For the first day or two of the mission, the crew stayed relatively close to Earth, close being a relative term when you are already 1,400 miles up. They used this time for something important, something that sounds, in its technical name, rather dry, but which is actually a matter of profound consequence. They performed proximity operations. This means that the crew took manual control of the Orion capsule and maneuvered it carefully near the spent interim cryogenic propulsion stage, the upper rocket stage that had placed them in orbit and was now drifting inertly nearby. They flew close to it, observed it, practiced the delicate navigation skills that future Artemis missions will need when they dock with other spacecraft in the vicinity of the moon. It is the kind of work that does not make headlines, but that makes everything else possible. And while this was happening, the 4 crew members were doing something else simultaneously, something that never stops during a spaceflight regardless of what else is on the schedule. They were adapting. The human body, when it enters microgravity, does not simply relax and enjoy the weightlessness. It begins immediately and somewhat urgently to recalibrate. Fluids shift. On Earth, gravity pulls blood and other fluids toward the lower half of your body. In microgravity, that pulling stops. Fluids redistribute, moving upward toward the head and torso. Many astronauts describe this in the early hours as feeling slightly congested, slightly full in the face, as though they have a mild head cold. It is not dangerous. It is simply the body adjusting to a world where the word down has temporarily lost its meaning. Muscles, which on Earth spend every moment of every day working against gravity, maintaining posture, supporting weight, providing the constant low-level effort required to simply stand, find themselves without that work. They begin immediately to weaken. Not dramatically in the first days, but measurably. Bones, which constantly renew themselves in response to the stress of bearing weight, lose density over time in microgravity as that stress disappears. This is one of the significant challenges of long-duration spaceflight. The skeleton, without the familiar signals that gravity provides, begins to change. And the cardiovascular system, which on Earth is designed to push blood upward against gravity to reach the brain, must reconfigure for an environment where that uphill effort is no longer needed. The heart adapts, and the blood vessels adapt. It takes time. The crew of Artemis 2 were scientific subjects as much as they were explorers. Throughout the mission, they monitored their own health, blood pressure, heart rate, sleep quality, cognitive performance, contributing data that will help protect future astronauts on much longer journeys. This is not a small thing. The next step after the moon is Mars. The distance to Mars is roughly 140 times the distance to the moon. A journey to Mars and back would take months, not days. Every piece of biological data gathered during Artemis 2, every measurement of how a human body responds to 10 days in deep space, feeds directly into the preparation for that longer journey. The crew were, in a quiet sense, donating their bodies to science for 10 days. Not in any dramatic way. Or they simply lived their lives under observation in an extraordinary place. Now comes the evening of the first day. The work near Earth's orbit is complete. The proximity operations are done. A small final burn of the interim cryogenic propulsion stage places Orion on a new path. A path that curves away from Earth. This burn lasts 5 minutes and 49 seconds. Not very long for a burn that changes everything. In those 5 minutes and 49 seconds, the spacecraft crosses a kind of invisible threshold. The velocity and direction of travel change just enough that Earth's gravity, which has held every human being who has ever lived, can no longer reach Orion with sufficient force to pull it back. The crew has entered what engineers call the translunar trajectory, the arcing path through space that will carry them over the next several days to the moon's neighborhood. This is the moment the crew left Earth's gravitational neighborhood. You might wonder what that feels like from the inside. The honest answer is probably not very dramatic. There is no sensation of crossing a line. The view from the window doesn't change perceptibly in a single moment. Gravity does not announce its loosening grip. The instruments would show the change. The numbers would confirm it. But the fact of it, floating in a small capsule, knowing that you have just left the neighborhood of your planet for the first time, that must settle differently. The deep dark had begun. Over the next several days, days 2 through 5 of the mission, Orion coasted, not under thrust, not burning fuel, simply moving, carried by the velocity that had already been imparted to it, following the curve that physics and mathematics had chosen. This is one of the most counterintuitive facts of space travel, and it is worth dwelling on because it changes how the journey feels. We tend to imagine spacecraft as things that must constantly push themselves forward. Engines firing, fuel burning, the way a car requires constant acceleration to maintain speed. But this is not how movement in space works. In space, there is no air resistance, nothing slowing you down. Once you have been accelerated to a given velocity, you maintain it essentially indefinitely without expending any additional energy. Orion, having been given its push by the interim cryogenic propulsion stage, simply continued. Gravity was not absent during the journey. Gravity is never absent. But the particular balance of velocities and distances meant that the spacecraft followed a curved path through space, technically falling, always falling, but in a very carefully chosen direction, curving around the Earth-Moon system in a path that led to exactly where it was intended to go. The crew was not flying through space. They were falling through it, gently, precisely, in the direction of the moon. This is a distinction that carries a kind of quiet beauty. There is something to sit with there, something that does not resolve quickly. The idea of falling as a form of travel. The idea that to go somewhere in space, you arrange yourself into the right kind of fall. Gravity is not an obstacle to be overcome. It is the medium through which the journey moves. Days passed. Inside the capsule, 16.5 feet wide, to roughly the size of a large camper van, home to 4 adults for 10 days, life found its rhythms. There were meals. 189 unique food and beverage items had been prepared for this mission. Barbecue beef brisket, macaroni and cheese, butternut squash, cookies, smoothies, coffee. During launch and landing, only ready-to-eat foods were permitted. Nothing that requires preparation during the most physically demanding phases of the journey. But in space, freeze-dried meals could be rehydrated using the water dispenser built into Orion systems and heated in a device about the size of a briefcase. A meal warmer carried to the moon. There was exercise, which in microgravity requires special equipment and deliberate effort. Resistive devices that simulate the stress of weight. You're maintaining the muscles and cardiovascular system that would otherwise quietly decline. There was sleep in sleeping bags, anchored gently against the interior of the capsule. And there was, on the first day of the mission, a malfunction. The toilet broke. Not catastrophically, not dangerously. But the liquid waste disposal system became non-functional, and the crew was unable to use it for most of the trip. They reverted to the same method used during the Apollo missions, bags and funnels, an approach that is precisely as unglamorous as it sounds, unchanged in its essentials from the technology of 50 years ago. Christina Koch's response to this, when asked about it later, was this: "We can't explore deeper unless we are doing a few things that are inconvenient." There is more wisdom in that sentence than it might first appear. The willingness to accept inconvenience, real inconvenience, not metaphorical inconvenience, in service of a larger purpose is not a small thing. It is not a minor detail about a plumbing malfunction. It is a statement about what exploration requires. And it was made calmly, without drama, by someone who was 200,000 miles from Earth at the time. By day 5, something changed. Not visibly, not dramatically, but in a precise physical sense, something significant occurred. Orion crossed the lunar sphere of influence. The lunar sphere of influence is not a visible boundary. There is no line painted in space, no change in the quality of the light, no sensation of crossing a threshold. It is a calculated point, a location in space where the moon's gravitational pull becomes stronger than Earth's. Before that point, the dominant gravitational force on the spacecraft is Earth's. After it, the dominant gravitational force is the moon's. The crew, in a very specific physical sense, was now falling toward the moon. Not toward Earth, toward the moon. 54 years of absence. 438 days of planning and preparation and training and quarantine. 8 minutes of rocket burn. And then, quietly, on day 5, crossing an invisible line in the darkness between worlds, beginning to fall toward the destination. The moon was still 2 or 3 days away, but it was pulling now. The mathematics of the universe had shifted, and the crew was on the other side of a boundary that most human beings will never cross. Outside the windows, the stars were different from how you see them on Earth. Here, above the atmosphere, or there is no scattering of light, no haze, no filtration of any kind. The stars do not twinkle. They are points, precise, unwavering, separated by perfect darkness. More of them than you can count. More of them than you have any frame of reference for. And ahead, not close, not yet, the moon, getting closer. One slow, patient kilometer at a time. It is worth pausing here. Not to hold anything back. The flyby, the silence behind the moon, all of that is coming, and it will arrive with the patience it deserves. But there is something in this particular moment, the coasting, the falling, the quiet days between Earth and moon, that asks for a moment of simple stillness before we go further. 4 people, a camper van-sized capsule, the broken toilet, the freeze-dried brisket, the 8-year-old boy's mascot floating gently in the corner, and outside the absolute black of interplanetary space, and the stars that do not twinkle, and the moon growing imperceptibly larger in the window. This is what exploration looks like from the inside. Not always grand, often quiet, sometimes inconvenient. Always asking the question, why did you come this far, and what are you willing to carry with you? They carried rise. They carried the name integrity. They carried Victor Glover's capacity for words that reach across 200,000 miles. They carried Christina Koch's calm in the face of broken plumbing. They carried Jeremy Hansen's willingness to make his first journey into space, a journey to the moon's neighborhood. And Reed Wiseman carried something private, a grief and a love, and the idea that a crater might yet carry a name. We will reach that moment in time. For now, the capsule is still falling toward the moon. Day 5 has passed. Day 6 is arriving, and the moon is very close now. Day 6 begins in silence, not the silence of sleep or the silence of a quiet room, or the silence of a field at night when the wind has stopped. Those silences are full of small sounds you did not notice until they paused. The breath of someone nearby, the distant movement of traffic, the soft electronic hum of a building doing its invisible work. The silence of deep space is different in kind, not just in degree. There is no medium through which sound travels out here. No air, no water, no material of any kind that could carry a vibration from one point to another. The engines, when they fire, create vibration that travels through the structure of the spacecraft and reaches the crew as sound. But outside the hull, there is nothing. A shockwave expanding from a supernova would travel in complete silence through the vacuum between stars. The universe, in its vast majority, is profoundly, absolutely, structurally silent. The crew of Orion Integrity have been living inside that silence for 5 days now. They have their own sounds, the hum of the life support systems, the occasional click of equipment, their own voices, the soft sounds of people moving in a small space. But the silence presses against the hull from every direction. It is always there, just outside. And today, on day 6, they are going to pass through the most complete version of it that any human being has ever experienced. But first, the moon. It is close now, closer than it has been to human eyes in 54 years. The crew can see it through their windows, not as the disk of light you see from Earth, familiar and distant, and somehow more conceptual than real. From 4,000 miles away, the moon is a landscape. It has texture, it has depth. The Terminator line, the boundary between lunar day and lunar night, cuts across it with extraordinary sharpness, because there is no atmosphere to scatter the light, no softening of the transition from brightness to darkness. Just a precise geological edge between illuminated rock and absolute shadow. The crew is close enough to see individual craters with the naked eye. Think about what that means for a moment. The moon is 250,000 miles from Earth on average. From that distance, the details of its surface resolve into the general impression of a bright disk. You can see the dark Maria, the ancient volcanic plains, as patches of deeper color. You can see with a good telescope the outlines of the largest craters. But the detail is distant, filtered by distance itself. From 4,000 miles away, the moon is not a disk. It is a world. They passed within 4,067 miles of the lunar surface at closest approach. And during the 7 hours of that approach, passage, and recession, the 7-hour observation window that the free return trajectory's geometry allowed, the crew did something that only 24 human beings before them had ever done. They looked at the far side of the moon. The far side. Let that phrase settle in its proper strangeness. The moon is tidally locked to Earth. This is a consequence of gravitational physics, the same force that guides the free return trajectory, working patiently across billions of years. The moon rotates on its axis at exactly the rate needed to always present the same face to Earth. It is not a coincidence. It is what happens, given enough time, when gravity acts on a rotating body orbiting a larger one. The rotation slows, adjusts, and eventually synchronizes. The result is that from Earth, you always see the same face of the moon. The near side, the one with the great dark plains of ancient lava, the Sea of Tranquility where Apollo 11 landed, the Sea of Serenity, the Sea of Storms, the familiar geography that humans have been looking at and mapping and telling stories about for as long as we have been capable of telling stories. The far side is something else entirely. It was first seen by human eyes in December 1968, when Apollo 8 swung around the moon, and Frank Borman, Jim Lovell, and William Anders became the first human beings to view a landscape that had been completely hidden from all of human history until that moment. Hidden not by clouds or distance or any technology, but simply by the mathematics of gravity working patiently for 4.5 billion years. The far side is rougher, more heavily cratered. It has fewer of the dark volcanic plains that characterize the near side. The great lava floods that filled the ancient impact basins billions of years ago seem to have occurred primarily on the Earth-facing hemisphere. The reasons for this asymmetry are still being studied, still being debated. The crust on the far side is thicker. The volcanic history is different. It looks ancient in a way that the near side does not. The near side, with its smooth, dark plains and its familiar features, has the quality of a landscape that has been, in geological terms, recently resurfaced. The far side looks like what the moon looked like before that resurfacing, a record of the early solar system's violence, preserved in stone. Only 24 people had ever seen it directly, with their own eyes. Through a window, looking out at rock, billions of people have seen photographs of the far side. The Soviet Luna 3 probe photographed it in 1959. Dozens of subsequent missions have mapped it in extraordinary detail. There are images of the far side that are scientifically precise and visually extraordinary. You can download them, you can print them, you can hang them on a wall. But photographs and eyes are different instruments. Photographs are processed by cameras, transmitted across space as data, reconstructed by software, displayed on screens. What your eyes do when you look at something directly is something else. Something that involves depth and parallax and the full biological machinery of human vision, evolved over millions of years to understand the three-dimensional world. When you look out a window at something real, you are doing something that no camera can replicate. 24 people had done that with the lunar far side. Artemis 2 added 4 more. 28 human beings, in the entirety of our species' existence, have looked at that landscape with their own eyes. You are not one of them. Almost certainly, neither am I. And there is something in that which is neither sad nor triumphant. It is simply one of the quiet boundaries of the human experience at this particular moment in history. We know the far side exists. We have seen it in images. We understand its geology in considerable detail. And we have sent 28 pairs of eyes to actually look at it. The crew of Orion Integrity were looking at it now. They were narrating what they saw, speaking into the mission record, describing geological features, commenting on color and texture and the precision of shadows in a place where the sun provides light, but the earth provides none. Their observations were being recorded. Scientists on the ground were listening. Every description of color nuance, every remark about the texture of ejecta around a crater, every observation about the way shadow fell across ancient terrain, all of it was science, being conducted in real time. 2 features in particular deserve their own moment. The first is Glushko Crater, 27 miles wide, roughly the distance across a mid-sized city. Impact craters are the moon's autobiography. They record every significant collision event in the moon's history, preserved in the absence of weather, tectonics, or erosion. Glushko is young, as lunar craters go, which means its features are sharp and well preserved. It is surrounded by white ejecta streaks, rays of bright material blasted outward by the impact and landing across the surface, in long, pale arcs extending up to 500 miles from the point of impact. From 4,000 miles away, those streaks are visible. 500 miles of bright rock, it fanned out from a single violent moment billions of years ago, still lying exactly where it landed. The second feature is stranger. More interesting, more mysterious. It is called Reiner Gamma. Reiner Gamma sits on the near side of the moon, visible in the final stage of the flyby as Orion began to swing back toward Earth. It is a bright, swirling pattern on the surface, not a crater, not a mountain range, not a lava plain. It is a brightness, a luminous, curved anomaly on the lunar surface that looks from a distance almost like a brush stroke. Here is what makes Reiner Gamma genuinely puzzling. The moon has no global magnetic field. Unlike Earth, which is wrapped in a powerful magnetic field generated by the motion of its molten iron core, the moon has no such field. Its interior does not generate the electrical currents needed. The moon is, magnetically speaking, essentially quiet, But Reiner Gamma sits on top of a localized magnetic anomaly, a small region of magnetized rock in a body that should not have it. And that localized magnetic field appears to be related to the bright swirling pattern visible on the surface. The magnetic field may be deflecting the solar wind, which constantly bombards the lunar surface and darkens it over time through a process called space weathering. Where the solar wind is deflected, the surface stays brighter. How did a localized magnetic field end up in a body with no global magnetic field? What event, what ancient collision or volcanic activity or plasma cloud magnetized that particular patch of rock and left it there for billions of years? Scientists have proposed several hypotheses, and none of them is definitively proven. The crew of Artemis 2 looked at Reiner Gamma from a distance that no human had approached since the Apollo era. Their observations, the precise colors, the quality of the brightness, the details visible at 4,000 miles that are not visible in any other way, will contribute to the ongoing effort to understand what it is and how it came to be. The universe keeps its secrets carefully, even when you fly 4,000 miles away from them. Now the crew turned their attention to something else, something that required no instruments, no scientific training, no geological knowledge. They turned to the window and they watched the Earth set. Earth set. The moment when Earth sinks below the lunar horizon. From the surface of the Earth, you watch the sun set. You watch it sink below the horizon, the planet rotating beneath you, the geometry of your position relative to the sun changing until the sun is no longer above your local horizon. Sunsets are among the most universally described of human experiences. Cultures across every century and every geography have watched the sun go down and felt something about it. From the moon's vicinity, you watch Earth set. The spacecraft's motion, curving around the moon, changes the crew's geometric relationship to their home planet. Slowly, over minutes, not the hours of a terrestrial sunset, but measurable, watchable, the Earth sinks toward the lunar horizon. The blue and white of it, the luminous presence of it against the black, and then it is gone, below the horizon, behind the moon, out of view. For the first time since humans looked back at Earth from the moon during the Apollo era, 4 people watched their entire world disappear. You might sit with that image for a moment. There's no way to rush it and have it land properly. Imagine you are inside Orion. The window is in front of you. Outside is the black of space, the gray of the moon below, the stars that do not twinkle. And there, slowly sinking, is the blue marble. Every person you have ever known, every city, every ocean, every mountain range, every child asleep in a bed, and every elder watching television, and every animal in every forest, and every ship on every sea. All of it, compressed into a single luminous object that is shrinking toward the edge of a gray, airless world. And then it is below the rim, and it is gone. The crew was not in danger. They knew they were not in danger. The physics of their trajectory were precise and trusted. This was planned. This was part of the mission. And yet, what does it mean to watch your world disappear? To be in a place where you cannot see home? Most of us have had the experience of traveling far enough that the familiar disappears. A long flight over an ocean, a journey into a landscape that holds none of the landmarks of your ordinary life. There is something in those moments, something that is not quite loneliness, but that is adjacent to it. A kind of heightened awareness that you are, in fact, somewhere specific, somewhere that is not everywhere else. The crew of Orion Integrity experienced that in its most absolute possible form. Earth was gone, but something else happened during the flyby that deserves its own moment of wonder. Something that no human being had experienced from this particular vantage point before. The sun disappeared. From behind the moon, from the other side of the geometry that creates a solar eclipse for people standing on Earth, the crew of Artemis 2 watched the sun go behind the moon. Solar eclipses, as seen from Earth, are extraordinary events. The moon, which is roughly 400 times smaller than the sun, but also roughly 400 times closer, appears almost exactly the same angular size in Earth's sky. On the rare occasions when the moon passes directly between Earth and the sun, it can block the sun almost perfectly, revealing the solar corona, the outer atmosphere of our star, normally invisible against the sun's overwhelming brightness, suddenly ghostly and luminous against the darkened sky. From space, from the other side, the geometry is reversed. The moon is no longer between you and the sun. You are already on the far side of the moon, swinging around it. What you see is the sun's light disappearing behind the gray rim of the moon. The corona becomes visible, that outstretched, shimmering veil of plasma that extends millions of miles from the sun's surface. No human being had seen a solar eclipse from this side before. Not from deep space, not from the moon's vicinity, not from a position that placed them, rather than the Earth, in the path of the moon's shadow. The crew used the opportunity. They were observers as well as travelers. During the eclipse, with the sun's direct light blocked, they could study the corona in detail not possible under normal circumstances. They watched for meteoroid impacts on the lunar surface, tiny flashes of light that occur when space debris strikes the moon, visible only when the surface is in shadow. They documented, they recorded. They carried forward in their observations the scientific work that justifies the expense and risk of sending human beings rather than robots to these places. Human eyes notice things differently than cameras do. Human observers can redirect attention in real time, following a detail that catches the eye, asking a question that the mission plan did not anticipate. There is a flexibility to human presence in space that no robot mission has yet fully replicated. And then they went behind the moon. The free return trajectory, the mathematical arc that the mission's designers had chosen with such extraordinary care, carried Orion into the shadow of the moon, into the region where the moon itself, that 4.5 billion-year-old sphere of rock, stood between the spacecraft and every transmitter and receiver on Earth. Radio signals travel at the speed of light. Nothing travels faster. But even at the speed of light, a signal cannot pass through a mountain of rock. It cannot curve around a planet-sized obstacle. The moon blocked the line of sight between Orion and Earth completely. Communication ceased. It did not fade gradually, the way a phone signal weakens as you drive into a valley. It stopped. One moment, there was a signal. The next, there was nothing. The moon had interposed its 4.5 billion-year-old mass between the crew and every other human being alive. This lasted approximately 40 minutes. In mission control, in the building in Houston, Texas, where the flight controllers sat at their consoles and watched their screens and spoke into their headsets to the crew moment by moment throughout the mission. The communication stopped. The screens showed what they showed. The data that was incoming stopped being incoming. There was no malfunction. It was working exactly as planned. But the crew was gone. The families of the 4 astronauts knew this was coming. Mission planners had explained it thoroughly, in advance, more than once. The physics of the trajectory made it inevitable. This is what happens when you fly around the moon. You go behind it. The signal stops. You wait. Knowing something is coming does not always change how it feels when it arrives. The families waited. The flight controllers waited. The reporters who were covering the mission waited. The millions of people watching live streams around the world watched their feeds show telemetry that was not updating, and waited. For 40 minutes, the crew of Orion Integrity were the most isolated human beings who have ever existed. Consider what that means carefully, because it is a claim worth examining. The most remote human explorers throughout history, the sailors who crossed unknown oceans, the polar expeditioners who walked into environments that would kill them if their equipment failed, the mountaineers at the summit of Everest in a storm, all of them were isolated by distance and difficulty. Communication was hard or impossible. Rescue was impossible. But they were on Earth. They were in an environment, however hostile, that was part of the same physical and atmospheric system as everyone else. There were directions they could walk in. There was a planet beneath their feet that connected them, eventually, to everywhere else. The crew behind the moon had none of that. There was no direction they could walk. The spacecraft was their entire world. Between them and every other person in existence stood 4.5 billion years of accumulated rock, 470 miles from top to bottom, utterly impassable, utterly opaque to radio waves. Their words, had they spoken to no one in particular, would have gone nowhere. There was no one to hear them within range of any medium that could carry sound. And the universe did not know or care. The laws of physics that placed them there also guaranteed, with perfect reliability, that the trajectory would carry them back out. The same mathematics that had put the moon between them and Earth would, in 40 minutes, remove it. The free return trajectory was not a hope. It was a calculation. It had been verified and re-verified by the accumulated work of engineers and mathematicians who had devoted entire careers to understanding orbital mechanics. But 40 minutes is 40 minutes. What do you do in the deepest isolation any human being has ever known? You work, probably. You monitor your systems. You observe your instruments. You look out the window at the lunar surface passing below you, the far side, the ancient cratered terrain, the landscape that only 28 people have seen, and you take it in. You exist in the moment, because the moment is extraordinary, and because there is nothing else to do but exist in it. There is something in this that is worth holding gently, without pressing on it too hard. The 40 minutes of silence behind the moon was not terrifying. It was not described by the crew as traumatic. It was, in the accounts that followed, described as profound, as the kind of stillness that changes you slightly, the way that any encounter with the genuinely vast and genuinely indifferent universe changes you slightly. The universe is not hostile, it is simply indifferent. There is an important distinction there. Hostile implies intent, the deep dark of space, the silence behind the moon. For the radiation of interplanetary space, none of these are hostile. They are simply what they are. The universe was not waiting for the crew to go behind the moon so that it could isolate them. It was simply being itself, operating according to its laws, which have been operating according to those same laws since before the Earth existed. The crew were, in a precise physical sense, inside the universe being itself. And that is different from being in danger. They were held, not by Earth's gravity, not by the moon's gravity, but by the mathematics of their trajectory, a path that the universe's own rules guaranteed would bring them back. 40 minutes passed, and then Orion emerged. From behind the moon, moving now away from the far side and back toward the near side, the spacecraft's position relative to Earth changed. The moon's rim, which had blocked all communication, was no longer blocking it. The line of sight between Orion's antenna and the receiving stations on Earth was restored. The signal came back. In mission control, screens updated. Telemetry resumed. 4 voices came back through the noise of interplanetary space, slightly delayed by the 1.36 seconds it takes light to travel 250,000 miles, but clear and present and real. 4 voices from the far side of the nearest world. They were fine. The systems were nominal. Everything was working. The 40 minutes had passed the way they were supposed to pass, and the Earth was rising. Earthrise. On Christmas Eve 1968, a photograph was taken from lunar orbit by astronaut William Anders aboard Apollo 8. But he had been reaching for a different camera when he caught the view through his window. The gray, airless curve of the moon's surface in the foreground, and above it, rising above the lunar horizon, the Earth. Blue and white, luminous against the absolute black of space. Fragile. Impossibly colorful against the gray of the moon and the black of everything else. That photograph is called Earthrise. It is among the most reproduced photographs in human history. It is credited by many environmental historians with changing the way humanity thought about its home planet, providing the first truly visceral image of Earth as a finite, beautiful, singular thing floating in darkness, which had to be cared for, which could be lost. The crew of Artemis 2 watched the Earth rise above the lunar horizon as they came back around the near side. They watched it come back, the world returning to view. The blue marble, reappearing above the rim of the moon, growing slowly more visible as the spacecraft's trajectory carried them away from the far side and back into the familiar geometry of Earth and Moon and Sun. This was the moment that Victor Glover chose to speak. It was Easter Sunday, April 6th, 2026. The crew was 250,000 miles from Earth, having just passed behind the moon, having just broken the record for the farthest any human beings have ever traveled from their home planet. Victor Glover shared a message. He spoke about where they were and what they could see and what it meant to him. He said something that traveled 250,000 miles at the speed of light and arrived on Earth and was received by millions of people watching. He said, "This is an opportunity for us to remember where we are, who we are, and that we are the same thing, and that we've got to get through this together." He said this looking at a planet he could cover with his thumb. You might read that sentence a second time, slowly if you like. Not because it is complicated, but because it is very simple and very true, and came from a place that made its simplicity feel different. He was not speaking from a stage or from a studio, or from any of the contexts in which people usually say things to many people at once. He was speaking from the void, from the neighborhood of the moon, from the most distant vantage point any human being had occupied in 54 years, and he said, "We are the same thing. We are the same." The overview effect, the cognitive and emotional shift that astronauts describe upon seeing Earth from space, is not a metaphor. It has been documented, studied, and described with remarkable consistency across decades of spaceflight. Astronauts from different countries, different backgrounds, different personalities, different eras have reported the same core experience. Seeing Earth from space changes something in how you understand your relationship to it. The borders between nations disappear. The scale of human conflict, of human difference, becomes harder to maintain against the backdrop of the planet's singularity. You see very clearly that there is one world, and it is very small, and it is very beautiful, and there's nothing else like it in the visible neighborhood. Victor Glover had just watched Earth disappear below the lunar horizon. He had spent 40 minutes behind the moon in the deepest silence any human being has ever known. And when the Earth came back, he looked at it and said, "We are the same thing, and we've got to get through this together." It is difficult to know how to respond to that, except to sit with it quietly. Now, something happened during the flyby that belongs in a category of its own. Something quiet and personal, and in its own way, as profound as any of the scientific observations made during those 7 hours. Reed Wiseman made a request. Mission protocol includes mechanisms for the crew to communicate with mission control about matters beyond the strictly operational. Wiseman, during the flyby, opened a communication and asked for something unusual. He asked permission to name 2 lunar craters. The official naming of lunar features is governed by the International Astronomical Union, a body of scientists that has maintained the authoritative catalog of the names of solar system features since 1919. Informal names proposed by crews during missions have, in the past, been submitted to the IAU and granted official status. Wiseman knew this. He made his request knowing that what he proposed, if approved, could become permanent. He proposed 2 names. The first, Integrity, for the crater to carry the name of their spacecraft. The second, Carroll, for his late wife. Mission Control granted both requests during the flyby. Somewhere on the moon right now, in the official record of the universe, in the catalog maintained by human beings to keep track of the features of the world nearest to their own, there is a crater named Integrity, and there is a crater named Carroll. Carroll, a name that most people reading or listening to this have never heard before. A name belonging to a woman who was not an astronaut, not a scientist, not a public figure of any kind. A woman who was loved and who died, and whose memory her husband carried with him to the moon's neighborhood in a 16.5-foot wide capsule and pressed quietly into the surface of another world. No one can visit that crater yet, No human being can stand on its rim and look in. The next crewed Artemis mission that lands on the moon is targeted for 2028, and even then, the landing site is planned near the South Pole. Not necessarily near the crater named Carroll. It may be many years before any human being stands close to it, but the name is there, in the record, on the moon. That is what exploration offers at its deepest level. Not just knowledge, not just data, not just the validation of systems and the confirmation of trajectories. It offers the chance to leave something of ourselves in places we have barely begun to reach. A name given across 250,000 miles as an act of love. The moon is 4.5 billion years old. It has no memory, no knowledge, no awareness of any kind. It does not know it is named. It does not know it carries Carroll. But we know. And that is the difference between a universe that contains intelligence and one that does not. We are the part of the universe that notices. We are the part that names. We are the part that makes the journey and leaves something behind. This is what makes those 7 hours at the moon so extraordinary. Not just the distance record, not just the eclipse and the Earthrise and the geological observations, but the quiet human fact of 4 people moving through an ancient place and marking their passage with the things they cared about. If you are settling in for the night or finding your way toward rest, we are glad you are here for this part of the journey. If this channel has become a place you return to, a subscription is a quiet way to make sure more nights like this one find their way to you. There is never any pressure. Only always an open door. Let us turn now to something that requires us to think about distance in a new way. At the farthest point of the mission, the point of maximum distance from Earth, the crew was 252,756 miles away. The previous record for the farthest any human beings had ever traveled from Earth was held by the crew of Apollo 13. In April of 1970, during what became one of the most dramatic emergency situations in the history of spaceflight, the Apollo 13 crew, Jim Lovell, Jack Swigert, and Fred Hayes, swung around the far side of the moon on a modified free return trajectory after an oxygen tank explosion crippled their spacecraft. They could not use the lunar module as planned. They could not land. They used the moon's gravity to redirect them back toward Earth, conserving the limited power remaining in their damaged systems. In the process, they reached a distance of approximately 248,655 miles from Earth. For 54 years, that was the record, the farthest human beings had ever been from their home planet. The crew of Artemis II, on April 6, 2026, surpassed it by 4,101 miles. They were the farthest human beings from Earth in all of recorded history. Not by a vast margin, not by millions of miles, by 4,101 miles, a distance that, in any terrestrial context, would be considered enormous, but that in the scale of space is a relatively modest extension of a record. The moon does not move in a perfectly circular orbit, it traces an ellipse, and the position of the far side varies depending on where the moon is in that ellipse. The mission's trajectory was planned to take advantage of this geometry, 4,101 miles beyond where any human being had gone before. The 4 crew members were simultaneously the 4 people farthest from Earth in human history. There were no other contenders. No one was at the International Space Station at that particular moment, 250 miles above Earth's surface, who was remotely close. The 4 people aboard Orion Integrity were the entire human presence beyond Earth, and they were 252,756 miles away. This broke another record as well. Apollo 8, in December 1968, carried 3 astronauts, Frank Borman, Jim Lovell, William Anders, to lunar orbit. They were the first human beings to travel beyond Earth's gravitational neighborhood, and they did so as a crew of 3. 3 people simultaneously in deep space. That record had stood since 1968. Artemis, II, carried 4. For 10 days, from launch to splashdown, the record for the most human beings simultaneously in deep space was 4. Set by Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. No moment in the history of the human species has seen 4 people so far from Earth at the same time. There is a number in the mission data that helps put the total journey in perspective: 695,081 miles. That is the total distance traveled by the Artemis 2 crew over the 10 days of the mission. Not the farthest point from Earth. That was 252,756 miles. The total accumulated distance of the journey, outbound and return, the curves and arcs of the trajectory, the full sweep of 695,081 miles. If you drove at highway speed, 65 miles per hour, without stopping, without sleeping, without any interruption at all, and it would take you approximately 1,060 days to cover that distance. Nearly 3 years of continuous driving. The crew did it in 10 days, and they did it not continuously under power, but mostly coasting. Gravity did the work. The mathematics of orbital mechanics, applied with extraordinary precision, carried a small capsule on an arc through the solar system and brought it home. Now there is something to understand about the specific path the mission flew. Something that is, in the quietest possible way, one of the most beautiful ideas in all of spaceflight: the free return trajectory. The name itself tells you something. Free return. A return that does not cost you anything, does not require an engine burn, does not depend on any system functioning correctly. A return that is guaranteed by the geometry of the path itself. Here is how it works. The trajectory is designed so that the combined gravitational fields of Earth and the Moon, 2 massive bodies pulling on a spacecraft with different strengths as the spacecraft moves between them, create a natural path that curves around the Moon and back toward Earth. The spacecraft enters this path, and physics does the rest. If every engine on Orion had failed simultaneously, completely and permanently, with no possibility of repair, the spacecraft would still have returned to Earth. Not to an ideal landing spot, not with optimal timing, but to Earth. The geometry would have brought it home. This is what engineers mean when they talk about safety margins. Not just redundant systems, not just backups for backups, but trajectories that are mathematically guaranteed to preserve life, even in catastrophic failure scenarios. The crew was never simply flying through space, they were falling through it, in a very carefully chosen direction. And the universe, following its own rules, was cooperating. There is something philosophically resonant in this that is easy to rush past. The free return trajectory uses the Moon not as an obstacle, not as a destination, but as a partner. The Moon's gravity, the same gravity that has been pulling on Earth, raising tides, slowing Earth's rotation over billions of years, locking itself into its tidally synchronized orbit, is incorporated into the plan. The planners did not fight it or ignore it. They included it. They counted on it. They designed a path that trusted the Moon's gravity the way you might trust a quiet, reliable, utterly indifferent colleague who always does exactly what physics requires. The Moon pulled the spacecraft around its far side and pointed it home. The crew did not fight the Moon to get home. They let the Moon help. They let the universe cooperate. There is something in that which feels, against all scientific objectivity, like grace. During the days of the outbound journey and the return, the quiet days of coasting, of meals and sleep and monitoring and the slow turning of the Earth from large to small and back again, the crew's bodies were being studied. Not just by the medical monitors and the data systems aboard Orion, but by a piece of science that deserves its own explanation because it points towards something genuinely remarkable. Aboard Orion, the Artemis 2 crew carried a set of tiny devices, smaller than anything you might imagine carrying on a mission to the Moon. These devices are called organ-on-a-chip constructs, and they are one of the most extraordinary developments in biomedical engineering of the last decade. An organ on a chip is exactly what the name suggests, and also far stranger than the name implies. It is a small device, transparent, made of flexible polymer, in which living human cells are grown in arrangements that replicate the microarchitecture of specific organs. A lung on a chip, contains human lung cells arranged with the same geometric relationship as in an actual lung. A bone on a chip contains bone cells arranged to replicate bone tissue structure. Fluid flows through channels in the device the way blood flows through capillaries, carrying oxygen and nutrients to the cells. These devices behave in testable ways like tiny versions of actual human organs. They respond to drugs, they display disease processes, they age. And crucially, they can be exposed to environments that human beings cannot safely be exposed to for research purposes. In the investigation called Avatar, a name that refers to the representation of a biological system in an engineered form, these tiny organ constructs were flown aboard Artemis 2 and exposed to the actual environment of deep space. The real radiation levels, the real microgravity, the real duration of the journey, not simulated in a laboratory, not approximated. The actual thing. When they return to Earth, when the laboratories receive these devices back from the mission and begin their analysis, scientists will be able to study what 10 days in deep space did to living human tissue at the cellular level. The radiation effects, the microgravity effects, the combination of both simultaneously, which cannot be replicated in any laboratory on Earth. This is data that does not exist anywhere else. It has never existed before. It is being created for the first time by this mission, in this moment, and it will feed directly into the question of how to protect the people who will eventually make much longer journeys. The months-long voyage to Mars. The years that a permanent lunar station crew might spend on the surface. The biology of long-duration spaceflight in deep space, which is genuinely different from the biology of long-duration spaceflight in low Earth orbit, where Earth's magnetic field provides partial protection against the cosmic radiation that is simply present, constant, and penetrating in the space between worlds. The radiation environment between planets is inhabited by two kinds of high-energy particles. The first kind comes from our own sun. Solar energetic particles are produced during solar flares and coronal mass ejections, enormous eruptions of plasma and magnetized material from the sun's surface. These events can produce sudden increases in radiation levels that can, in extreme cases, pose a health risk to unprotected crew members. The mission flew during a period of heightened solar activity, and NASA and NOAA maintained 24-hour real-time monitoring of the sun throughout the 10 days, watching for eruptions that might require the crew to move to a more shielded area of the capsule. No such event occurred during Artemis 2, but the monitoring was constant, the protocols were in place, and the data gathered on solar particle levels during the mission contributes to the growing understanding of the space weather environment that future, longer missions will have to navigate. The second kind of radiation is older, more mysterious, and in some ways more challenging to manage. Galactic cosmic rays are not from our sun. They come from outside our solar system, from distant supernova, from the remnants of stellar explosions that occurred millions or billions of years ago in galaxies far removed from our own. These are extraordinarily high-energy particles, moving at close to the speed of light, crossing the vast distances between stars, and arriving in our solar system from every direction simultaneously. On Earth, you are protected from galactic cosmic rays by two things: the Earth's magnetic field, which deflects many of them before they reach the atmosphere, and the atmosphere itself, which absorbs most of the rest. At sea level, you receive only a tiny fraction of the cosmic ray flux that exists in interplanetary space. In deep space, there is no magnetic field. There is no atmosphere. The cosmic rays come from every direction, at their full flux, and they pass through the walls of spacecraft, as if those walls were not there. They interact with the material of the hull, sometimes producing secondary particles that can be more biologically harmful than the original ray. They interact with DNA in cells, potentially causing breaks that the body's repair mechanisms must fix, or if the repair fails, potentially contributing to long-term cancer risk. The full long-term biological effects of extended exposure to galactic cosmic rays in human beings are still not well understood. They cannot be studied fully on Earth, because Earth's protection prevents us from experiencing the full flux. They cannot be studied fully at the International Space Station, which is still within Earth's magnetic field. They can only be studied in the actual environment of deep space. Every day the Artemis II crew spent beyond Earth's magnetic field contributed data to this question. Not enough to resolve it. 10 days is not enough to show the long-term effects that accumulate over months or years, but enough to add to the growing body of evidence. Enough to validate models. Enough to identify where the models need refinement. The data the crew generated simply by being there, by existing in that environment and allowing instruments to measure it, is science that will take months and years to fully analyze. They were, in the quietest possible sense, pioneers of medicine as much as of exploration. Let us speak now about something that has been mentioned but not yet fully explored: the question of what it was like to be inside the capsule during those 10 days. Not the science of it, not the records, the texture of daily life in a 16.5-foot wide space, 200,000 miles from home. The Orion crew module is roughly the size of a large camper van. If you have ever spent time in one, sleeping in the back, eating at a small fold-out table, managing your morning routine in a compact bathroom, moving carefully around another person because the space does not easily accommodate two people moving in the same direction, then you have a physical intuition for the scale of what 4 people inhabited for 10 days. Now remove the bathroom. Now remove gravity. Now move the entire vehicle 250,000 miles from the nearest gas station, or hospital, or other person. The sleeping arrangements in Orion are sleeping bags, secured to the interior of the capsule to prevent the sleeper from drifting. In microgravity, there is no up or down. You can sleep in any orientation, and your body does not strongly prefer any particular one. Crew members sometimes float with their knees slightly bent, their arms drifting forward naturally in the way that the human body assumes when every muscle simultaneously relaxes. It is, by all accounts from astronauts across many missions, deeply restful once you stop fighting the strangeness of it. Eating involves some care. Liquids released from a container in microgravity form spheres that float and drift and, if not consumed quickly, eventually contact surfaces and spread. Crumbs do the same. And in a spacecraft, free-floating crumbs represent a genuine hazard if they find their way into air vents or electronic equipment. The food for Artemis II was prepared and packaged with all of this in mind. 189 carefully engineered items were designed for nutrition and calorie density and ease of consumption in weightlessness. The crew's exercise equipment takes up space. The medical monitoring equipment takes up space. The suits, when not being worn, take up space. In a 16.5-foot wide capsule with 4 people, space is a managed resource, constantly. And through all of this, the meals and the sleep and the exercise and the monitoring and the conversations with mission control, the windows were there. Whatever window was available at any given time showed something that no amount of preparation fully prepares you for. The Earth, shrinking, the stars, unblinking, the moon, growing, the absolute black of interplanetary space in every direction, as far as the eye can detect and further. What does it do to you, to live with that view for 10 days? The overview effect has been described by astronauts across decades. It is not a single moment. It is a slow shift, an accumulation of views and silences, and the growing awareness of perspective that changes how you carry yourself when you return. Edgar Mitchell, who walked on the moon during Apollo 14, described a sudden sense of universal connectedness, of seeing the universe not as a collection of separate objects, but as a single, intelligent, deeply ordered system, of which he was a part. Not every astronaut reports it the same way. Some describe it primarily as intellectual, a clarifying of understanding rather than a spiritual experience. Some describe it as overwhelming. Some describe it as quietly peaceful. But almost all describe some version of the shift. Christina Koch looked out the window and saw what every astronaut before her has described: the blue marble, fragile, luminous, impossibly beautiful, and impossibly small. She took photographs that will outlast her, and all of us. The Earth does not know it is being photographed. It does not know it is beautiful. It does not know that a woman in a capsule the size of a camper van, 250,000 miles away, is pressing her face to a window and looking at it with the full weight of human feeling. Only we know that. Only creatures who can travel far enough to look back can know what home looks like from outside. And the crew of Orion Integrity knew it for 10 days, from a distance no human being had reached in 54 years, before the far side had been rounded, before the signal went silent and returned, and before the crater was named. There was another quiet human moment worth knowing about. As Orion approached the moon on day 5 and day 6, the crew were crossing a boundary that has no physical marker and no official scientific definition in quite the way a planetary boundary does, but that is recognized implicitly in the history of spaceflight. They were entering the vicinity of the moon, the neighborhood of a world that is not theirs. At maximum distance, the moment of the record, the crew's radio signals took 1.36 seconds to travel one way between the spacecraft and Earth. 1.36 seconds. It does not sound like much. In a conversation, you might not notice a 1.36 second delay. People speak, pause, gather thoughts. A second and a third of a second is well within the range of normal conversational rhythm. But this delay was not caused by hesitation or thought or lag in a communications network. It was caused by distance. It was the time it takes light, the fastest thing in the universe, the ultimate speed limit of physical reality, to cross the gap between the spacecraft and the planet. In mission control, when a crew member finished a sentence, that sentence had not yet arrived on Earth. It was still traveling, still crossing the void between two worlds at the speed of light, covering 186,000 miles every second. And then, 1.36 seconds after it was spoken, it arrived. And the response, when it came, took another 1.36 seconds to travel back. A question asked and an answer received. 2.72 seconds, minimum, regardless of how quickly anyone on either end thinks or speaks. The delay is built into the fabric of the universe. It is the sound of distance made audible. For 10 days, every conversation between the crew and the Earth carried that slight hesitation. That gap that was not a gap in thought or connection, but a gap in space. A reminder, subtle and constant, that they were genuinely far away, that they were not in the next room, not in orbit, not in a place that could be reached quickly. They were out there, and the mission continued. The days after the flyby were quieter, in some ways, than the days before it. The most extraordinary hours had passed. The far side had been seen and documented. The record had been broken. The craters had been named. Earth had set and risen again, as the spacecraft swung around the moon and began the long arc home. The moon's gravity, having done its work, had redirected Orion. Not with a dramatic burn, not with any active intervention, simply by existing. By being as massive as it is, precisely where it is, the moon had turned the spacecraft around and aimed it back toward Earth. Small correction burns followed. Not the 5-minute and 49-second burn of the translunar injection. These were brief, 8 seconds, 15 seconds, tiny pulses of thrust that fine-tuned the return trajectory with extraordinary precision. The difference between a capsule landing in the right patch of ocean and one landing somewhere it was not intended to be is, over the distance of 250,000 miles, measured in fractions of a degree of angle. The correction burns addressed those fractions, and the crew chose their music for the journey home. 2 songs, selected in advance, waiting on the playlist for the moment when the moon was behind them and Earth was ahead. Run to the Water by Liv, and Free by Zach Brown. After 10 days in the deep dark, those words must have meant something different than they ever had on Earth. Run to the Water, Free. The home planet was growing again in the window. Day by day, in increments, Earth was getting larger, getting more detailed. The coastlines resolving from abstractions into recognizable shapes. The weather systems visible. the blue of the oceans deepening as the distance decreased and the disk grew in angular size. They were going home. And home, the same home that had shrunk to the size of something you could cover with your thumb, was ready to receive them. The final approach was beginning. The physics of re-entry was waiting. The Pacific Ocean was waiting. The USS John P. Murtha was waiting. With recovery personnel, with medical teams, with the gentle absurdity of gravity about to reassert itself on 4 bodies that had spent 10 days learning, again, how to live without it. What comes next? The fire of re-entry, the extraordinary physics of a heat shield built to survive temperatures that approach the surface of the sun, the skip across the upper atmosphere like a stone on water, and the final descent on enormous white parachutes to the Pacific. All of that is a story in itself. A story that carries its own science, its own elegance, its own quiet wonder. The journey is almost complete, but not quite yet. There is still the fire to pass through first, and on the other side of the fire, home. The fire begins quietly, not with sound. There is no sound in space, and the upper atmosphere, where re-entry begins, is thin enough that sound has not yet found its medium. It begins with light. A glow. The faintest luminescence appearing at the edges of the heat shield, as the first tenuous molecules of atmosphere make contact with a capsule traveling at 24,700 miles per hour. 24,700 miles per hour. Let that number arrive slowly. Do not rush past it. Let it settle the way a stone settles through deep water, gradually, finding its level. A commercial airliner, the kind you may have traveled in, moves at roughly 570 miles per hour at cruising altitude. This is fast by any human standard. It is fast enough that a journey which would take a week to drive takes a few hours to fly. It is fast enough that the ground below becomes abstract, towns and rivers reduced to a patchwork of shapes and colors. Orion Integrity, returning from the moon, was traveling 39 times faster than that. 39 times. Not 39% faster, 39 times. If you could somehow place a commercial airliner and the returning Orion capsule at the same starting line and release them simultaneously, by the time the airliner had traveled 1 mile, Orion would have traveled 39 miles. And all of that velocity, the kinetic energy of a capsule and 4 human beings moving at Mach 33, had to go somewhere. The first law of thermodynamics does not negotiate. Energy cannot be destroyed. It can only be transformed. The kinetic energy of the Artemis II crew returning from the moon was transformed, in the upper reaches of Earth's atmosphere, into heat. Specifically into approximately 5,000 degrees Fahrenheit at the surface of the heat shield. 5,000 degrees Fahrenheit. The surface of the sun, the visible surface, the photosphere, the layer from which the sunlight that warms your face on a clear day originates, is approximately 10,000 degrees Fahrenheit. The heat shield of Orion Integrity, during re-entry, reached half that temperature, hotter than lava, hotter than the interior of most industrial furnaces, hotter than the melting point of steel, of titanium, of most metals and ceramics that the word heat-resistant is normally applied to. At 5,000 degrees Fahrenheit, almost everything you can name would vaporize. The crew inside the capsule, during this event, were comfortable. They were not merely surviving. They were not enduring temperatures that they could feel through the walls. The interior of the capsule remained at a human habitable temperature. The 4 astronauts, strapped into their seats for re-entry, experienced the fire as something largely external to their awareness, a glow visible through the windows, a plasma sheath of superheated gas surrounding the capsule, the vibration of the atmosphere resisting their passage through it. The G-forces during re-entry pressed them into their seats, not dangerously, not beyond what training and physiology can handle, but perceptibly. A few centimeters of engineered material separated them from the temperature of the sun's surface. That sentence deserves a moment of quiet. A few centimeters, the thickness of a few stacked paperback books. That is the physical distance between 5,000 degrees and a habitable environment, between the fire of atmospheric re-entry and 4 human lives. Not meters, centimeters. The material responsible for this extraordinary separation is called AV coat. It is an ablative material, and the word ablative is important because it describes a mechanism that is elegant in its physics and counterintuitive in its engineering logic. Most materials that we think of as protective work by resisting. A winter coat resists the passage of cold air. A concrete wall resists impact. The logic of resistance is familiar. Make the material strong enough, dense enough, impenetrable enough, and the threat cannot reach what lies behind it. Ablative materials work differently. They do not resist. They sacrifice. AvCoat is designed to char. As the heat of reentry reaches the outer surface of the heat shield, the AV coat material absorbs that energy and begins to break down. It chars. It flakes away. And as it does so, it carries the thermal energy away from the capsule, not through the material and into the interior, but outward, away, into the superheated plasma of the atmospheric boundary layer. The heat does not pass through the shield. It removes the shield, layer by infinitesimal layer, taking itself with it as it goes. This is ablation, and it is one of the most quietly brilliant ideas in the history of aerospace engineering. The shield does not survive the re-entry intact. It is consumed by it, and in being consumed, it protects everything inside. The heat shield on Orion is the largest ever built for a crewed spacecraft. We're 16.5 feet in diameter, the same width as the capsule itself. It was not the first time an ablative heat shield had protected a crew returning from the moon. The Apollo capsules used a similar principle, but the Orion heat shield represents decades of refinement, improved materials, better understanding of the ablation process, and the specific demands of returning from lunar distance, rather than just Earth orbit. There is a detail about this heat shield that is worth knowing because it illustrates something important about how engineering actually works in practice, how knowledge accumulates through failure and discovery rather than through perfect design from the beginning. After Artemis 1, the uncrewed test mission in November 2022, engineers examined the heat shield that returned from that flight. They found something unexpected. The ablation had not occurred uniformly. There were areas where the material had burned away more than the models predicted, and the pattern of char loss was not what the engineering simulations had anticipated. The outer surface of the AV coat had behaved differently in actual flight conditions than it had in ground testing. This was not a failure of the heat shield. The capsule had returned safely. The material had done its essential job. But the unexpected pattern was a signal, a message from the physical world to the engineers who had built models of it saying, "Your model is not quite right." Investigation revealed that trapped gases within the AV coat material were affecting how it ablated, creating subtle variations in the charring process that had not been fully captured in ground-based testing. And the physics of ablation in the specific conditions of lunar return re-entry, the particular combination of speed, atmospheric density, angle, and thermal environment, was more complex than the models had represented. The engineers revised their understanding. They flew Artemis 2 with that revised understanding incorporated. And they have planned further heat shield redesigns for Artemis 3, based on what the data from both missions is teaching them. This is how engineering works. Not by getting everything right the first time, by learning, by building something real, flying it in the actual environment, observing what happens, comparing it to what was predicted, identifying the discrepancies, and returning to the drawing board with better information. The universe is the ultimate test environment. No laboratory on Earth can fully replicate the conditions of lunar return re-entry. The only way to know exactly how your heat shield behaves at Mach 33 is to take it to Mach 33. And so they did. Now there is one more piece of the re-entry physics that deserves its own moment, because it is one of the most quietly elegant ideas in the mission, and because it illustrates, again, that recurring theme of the Artemis 2 story, using the universe's own forces rather than fighting them. The skip re-entry. You may have skipped a stone on water as a child, or you may have watched someone else do it. That flat trajectory that sends a disk of rock bouncing across the surface of a pond in a series of diminishing hops before it finally loses momentum and sinks. The stone does not penetrate the water on the first contact. The angle of approach and the surface tension of the water create an aerodynamic effect that lifts the stone back into the air, briefly, before it comes down again. Orion's reentry was designed to use a version of this principle, applied to the atmosphere instead of water. On day 10, as the capsule encountered the upper reaches of Earth's atmosphere, it did not plunge straight down. It struck the atmosphere at a shallow angle, used the aerodynamic lift generated by its shape and the density of the air to bounce, very slightly, very briefly, back up above the sensible atmosphere. It left the atmosphere for a moment, and then it came back in on a second, final re-entry trajectory. 2 contacts with the atmosphere rather than 1. This is called a skip re-entry, and it serves 2 important purposes. The first is precision. Once a spacecraft returning from the moon approaches Earth at an angle, from a specific direction, at a specific speed. Without any correction, the landing zone, the patch of ocean where the capsule will come down, is determined by all of those factors, and there is limited ability to adjust it. By skipping off the atmosphere and re-entering on a modified trajectory, the guidance system gains an additional degree of control over where, precisely, the capsule will land. The recovery ships can be positioned with greater confidence. The retrieval is safer and faster. The second purpose is comfort. A direct single-contact re-entry from lunar velocity generates significant G-forces, the crushing weight of deceleration pushing the crew into their seats. And the skip re-entry distributes that deceleration across 2 contacts with the atmosphere rather than 1, reducing the peak G-force the crew experiences. It is a gentler way to come home, engineered into the trajectory itself. The atmosphere, once again, was not an obstacle, it was a tool. The same air that surrounds and sustains every living thing on Earth, the medium through which birds fly and weather moves and human voices carry, was being used deliberately and precisely to guide a spacecraft home from the moon. The glow intensified. Outside the windows of Orion Integrity, the plasma sheath was at its peak. Superheated gas, ionized by the violence of the capsule's passage through the air, surrounded the spacecraft completely. Radio communications were briefly interrupted, the plasma itself blocking signals, creating a brief communication blackout that had nothing to do with the moon and everything to do with the physics of hypersonic flight through an atmosphere. A blackout on the way in, and a blackout on the way home. 2 silences separated by 10 days of the most extraordinary human journey in half a century. Then the plasma cleared. The capsule had slowed enough that the heat was diminishing, the ionization decreasing, the physics of hypersonic flight giving way to the more familiar physics of supersonic and then subsonic flight. The AV coat had done its work and carried its heat away. The capsule was intact, the crew was unharmed, and then the parachutes opened. First the drogue chutes, small, high-speed parachutes designed to stabilize the capsule's orientation and begin the deceleration process at altitudes where the air is still thin. And then the main chutes, 3 of them, each enormous, each a hemisphere of orange and white fabric billowing open against the blue California sky. From below, if you were watching, from a ship or from a helicopter flying at a distance, what you would see is a small dark object trailing light against the sky, and then 3 great flowers opening above it, slowing it, the capsule swinging beneath them like a pendulum finding its natural arc, descending now at a speed that the Pacific Ocean could receive without harm. The transition from Mach 33 to a gentle descent under parachutes is one of the most extraordinary velocity changes in any human endeavor. From 24,700 miles per hour to roughly 17 miles per hour at touchdown. Not gradually, not over hours, but in the span of minutes. The physics of the heat shield and the skip re-entry and the parachutes orchestrated together to achieve this, each stage handing off to the next, the accumulated violence of velocity dissipated piece by piece until there was nothing left of it but a capsule and 3 open parachutes and the quiet morning air of the California coast. The Pacific Ocean off San Diego is not, on most mornings, a dramatic place. It is wide and gray-blue and moves in long swells that have traveled thousands of miles from the open ocean to arrive here. Pelicans cross the horizon in their characteristic straight-line formations. Container ships pass in the middle distance. It is ordinary water, doing ordinary water things. On the morning of April 10th, 2026, it received something extraordinary. Orion integrity settled into the swell. The capsule floated. The parachutes, released and drifting, lay across the water nearby. The USS John P. Murtha, the Navy ship assigned to the recovery, moved toward the capsule. Recovery divers entered the water. The hatch was located, assessed, confirmed safe. The mechanism was operated. The hatch opened. From inside the capsule, from inside the space the size of a large camper van that had been home to 4 people for 10 days, that had carried them to the moon's neighborhood and back, that had borne the name Integrity across 695,081 miles. 4 people prepared to return to a world that has gravity. This is a small thing, and also not a small thing at all. After 10 days in microgravity, the human body has adapted. Partially, not completely. 10 days is not long enough for the adaptations to become fixed. But the vestibular system, the organs in your inner ear that detect acceleration and orientation and allow you to know, without looking, which way is up, has quietly recalibrated. It has begun to interpret the absence of gravitational pull as normal. It has stopped expecting the signal of weight beneath your feet. When gravity returns, when you step out of a spacecraft after days in microgravity and feel the full weight of your own body pressing down on your feet, your legs, your spine, the vestibular system must recalibrate again. And this recalibration is not instantaneous. It is disorienting, sometimes nauseating, sometimes simply strange. Your head, which in microgravity weighs nothing in a functional sense, weighs 10 to 12 pounds again. Your arms, which have drifted freely, must be supported by muscles that have been doing less work for 10 days. Your cardiovascular system, which adapted to a world where pumping blood uphill to the brain was unnecessary, must readjust to the original challenge of keeping the brain supplied against the pull of gravity. The body is remarkable in its adaptability. It is equally remarkable in how quickly it commits to whatever environment it finds itself in, and how thoroughly it must recommit when that environment changes back. The crew of Artemis II, within hours of splashdown, underwent their first post-flight medical evaluations aboard the USS John P. Murtha. Cardiovascular function assessed, fluid balance measured, vestibular system tested. The simple, ancient test of closing your eyes and extending your arms, checking whether the proprioceptive sense is telling the truth again. Musculoskeletal changes noted. Blood drawn for laboratory analysis that will continue for weeks and months. All of this data, every measurement from the moment of splashdown backward through 10 days of in-flight monitoring and forward through weeks of post-flight evaluation, will be compared to the pre-flight baselines established during the months before launch. The difference between who these 4 people were before they left Earth and who they are now that they have returned tells scientists something about what deep space does to a human body. And what it tells them will change how the next crew is prepared. And the crew after that. This is the quiet continuity of science. Not a single dramatic discovery, but an accumulation of understanding, each mission building on the last, each data set refining the picture, until someday, in ways that are not yet fully predictable, the picture is complete enough to act on confidently. Let us speak now about what scientists are specifically examining as of this moment. The lunar geology photographs taken during the 7-hour flyby observation window are being analyzed at NASA and partner institutions by teams of geologists and planetary scientists. They are looking for details that contribute to the ongoing work of understanding the moon's ancient history, the volcanic episodes that created the Great Dark Maria, the impact events that shaped the current surface, the subtle variations in color and texture that encode information about composition. The photographs are high resolution, They cover terrain that has been photographed before by robotic missions. But there is something different about images taken by human observers with human-directed cameras from a specific, chosen perspective. The crew could point their cameras where their eyes led them. They could zoom in on a detail that caught their attention. They could follow a curiosity. Reiner Gamma is among the features receiving particular attention. The bright, swirling magnetic anomaly remains unexplained, and the images taken during the flyby, at an angle and from a distance not previously available to any camera system, may provide new information about the structure of its boundaries, the gradients in its brightness, and the relationship between its surface expression and the underlying magnetic field. This is how science often works at its frontier, not with a single definitive answer, but with new data that reshapes the question. Scientists examining Reiner Gamma after Artemis II may not solve the mystery. They may find that their previous models need more revision than they thought. They may find that the mystery is deeper than it appeared. The universe keeps its secrets carefully, even when you fly 4,000 miles away from them. The Avatar organ-on-a-chip devices have returned to their laboratories. In the weeks following splashdown, teams of biomedical engineers and biologists are analyzing what happened to those tiny constructs of living human tissue during 10 days in deep space. The radiation exposure, the microgravity effects, the combination of both, a combination that cannot be reproduced on Earth, that exists only in the actual environment beyond our planet's protection. The results of this analysis will take months to publish fully, but they represent data that is genuinely new to science. Data about the behavior of human biological systems in the environment that any Mars-bound crew will spend months traversing. Data that may reveal cellular damage patterns, adaptation mechanisms, or vulnerabilities that were not previously measurable. A small helium leak was detected in the European Service Module's propulsion system during the mission. This is worth mentioning not because it was dangerous, it was not, but because of what it illustrates about how the engineering process works. The European Service Module is the component built by Airbus for the European Space Agency that attached to the back of the Orion crew capsule and provided propulsion, power, and a significant portion of the life support resources for the mission. It was built to an extraordinary standard. It was tested extensively before flight, and during flight, a small amount of helium, used to pressurize propellant tanks, leaked from a fitting in the propulsion system. Not enough to compromise the mission, not enough to affect crew safety. A small, contained leak in a system with sufficient margins to accommodate it. But it happened, and the engineers are analyzing it now. Not with frustration, not with the sense that a failure has occurred, but with the careful attention of people who know that a small, unexpected behavior in a real operating environment is worth more to the improvement of future hardware than years of additional ground testing. What did the helium do? At what rate did it leak? Under what conditions? What does that tell us about the fitting that failed, and about the design of the propulsion system, and about how to build a better version for Artemis III? These questions are being answered now. Quietly, in engineering offices, in laboratories, by people whose names will not be in the headlines, but whose work is the foundation on which the next mission will stand. Artemis III is targeted for 2028. Let the weight of that land gently, not as urgency. There is no urgency here, but as a horizon worth looking toward. Artemis III will not merely fly to the moon's vicinity. It will land. For the first time since December 1972. For the first time since Gene Cernan climbed into the lunar module and spoke his words of departure and left. For the first time in more than half a century, human boots will press into the lunar surface. The planned landing site is near the lunar South Pole. This choice is not arbitrary. The lunar South Pole is one of the most scientifically significant locations in the solar system that human beings could reach in the near term. It sits on the rim of some of the largest and oldest impact craters on the moon, basins so deep, so large, that their floors have not seen direct sunlight for billions of years. In those permanently shadowed regions, where sunlight never reaches and temperatures hover near absolute zero, water ice has been confirmed. Water ice on the moon. Think about what that means. Water, H2O, the molecule without which life as we understand it cannot exist, the molecule that covers 70% of Earth's surface and constitutes roughly 60% of the human body, has been sitting, frozen, in the dark floors of lunar craters for billions of years, delivered there perhaps by the same comets and asteroids that delivered water to the early Earth, preserved by the permanent shadow, waiting. What it means for exploration is significant. Water ice can be split, with energy, into its component elements, hydrogen and oxygen. Oxygen can be used for breathing. Hydrogen can be used as rocket propellant. Oxygen can also be combined with hydrogen as rocket propellant. A resource sitting on the surface of the moon, inaccessible in principle, could reduce the amount of material that needs to be launched from Earth for future missions. It could change the economics of deep space exploration entirely. But exactly how much water ice is there? How deep does it go beneath the surface? How pure is it? Is it clean water, or is it mixed with regolith, with dust, with other frozen compounds in ways that would make extraction difficult? Is it accessible with the tools future crews will carry? These questions remain open. They are among the most important questions that Artemis 3, landing at the South Pole, will begin to answer directly. And every lesson learned during Artemis 2, about life support, about crew health, about the behavior of spacecraft systems in the deep space environment, and about the human factors of living in a confined space far from Earth, feeds directly into the preparation for that landing mission. The gap between Artemis 2 and Artemis 3 is not a pause. It is preparation. Every data point, every observation, every unexpected small helium leak, and every organ-on-a-chip result, and every photograph of Reiner Gamma is being incorporated into the planning for what comes next. The moon has been patient for 4.5 billion years. It can wait 2 more. Beyond the moon, the conversation must eventually turn to Mars. It usually does in any serious discussion of why human beings are returning to the moon. Not because the moon is merely a stepping stone. It is a destination in its own right, a world of extraordinary scientific interest. A place where human beings could live and work and learn things that cannot be learned from Earth or from Earth orbit. But because everything we learn about keeping human beings alive and functioning in deep space for extended periods applies, with amplification, to the eventual question of Mars. The distance to Mars varies. Mars orbits the Sun at a different distance than Earth, and both planets move, so the gap between them changes constantly. At closest approach, when both planets are on the same side of the Sun and Mars is nearest, the distance is roughly 34 million miles. At farthest approach, when the Sun lies between them, it is over 250 million miles. A one-way journey to Mars, when the planets are favorably aligned, takes roughly 7 to 9 months. The moon is 250,000 miles away. The Artemis 2 crew reached it in about 5 days of travel, having been accelerated by one of the most powerful rockets ever built. Mars is, at closest approach, roughly 140 times farther. At that distance, a radio signal takes between 3 and 22 minutes to travel one way, depending on orbital positions. Mission controllers could not have a conversation with a Mars crew. The communication delay would be so large that every exchange would be a letter, not a phone call. The crew would need to be, in a profound sense, autonomous. The radiation environment on a Mars transit would dwarf the 10 days of Artemis 2. The galactic cosmic rays, the solar energetic particles, the months of exposure to the deep space radiation environment would accumulate in the bodies of a Mars crew in ways that 10 days simply cannot simulate. But 10 days provides data. 10 days provides avatar organ chip results. 10 days provides a baseline of biological measurements against which future, longer missions can be compared. The knowledge begins here, and there is something quietly extraordinary about that phrase. The knowledge begins here, because it situates this moment in a chain that reaches backward and forward simultaneously. It reaches backward to Apollo 8, and the first human eyes to see the lunar far side, to Gene Cernan's final footprints in the lunar dust. to the half-century of waiting and learning and building that made Artemis 2 possible. And it reaches forward to Artemis 3's boots on the southern polar highlands, and to whatever mission carries human beings for the first time into the long dark between Earth and Mars, and to the first human footprint on a world that is not the moon. Artemis 2 is a link in a chain, an extraordinary link, a record-breaking link, a link that carries the names of 4 remarkable people and the memory of Carroll and the imagination of an 8-year-old boy named Lucas. But a link nonetheless. Part of something that began long before it and will continue long after. This is perhaps the most accurate way to understand what happened on April 1st through April 10th, 2026. Not as a destination, but as a passage. Not as an ending, but as a particular beginning. Now let us return to something we have not yet fully explored. Something that has been present throughout this journey, but that deserves its own quiet examination. The question of what it means to trust something that far from home. When Victor Glover floated in the capsule and looked at Earth through the window, he was trusting something. Not in a vague or metaphorical sense, in a precise, physical, consequential sense. He was trusting the trajectory calculation. He was trusting the heat shield. He was trusting the parachutes. He was trusting the life support system that was removing carbon dioxide from the air he breathed and replacing it with oxygen. He was trusting the food packaging that kept his meals from contaminating his environment. He was trusting the suit that would protect him in the event of a pressure breach. He was trusting the people in mission control who were watching his telemetry and monitoring the sun and making decisions about correction burns. He was trusting, in other words, the accumulated knowledge of thousands of human beings across decades of work, engineers and mathematicians and biologists and chemists and test pilots and systems analysts and mission planners, all of whose work had converged in this capsule, in this trajectory, in this moment. That is an act of extraordinary trust. And it is worth naming it clearly, because trust of that magnitude does not appear from nowhere. It is earned, slowly, through demonstration, through Artemis 1 flying without crew and returning intact, through years of testing systems in conditions that simulate as closely as possible the real environment, through the careful work of engineers who, when they discovered unexpected ablation patterns in a heat shield, did not dismiss the finding, but investigated it fully and revised their understanding before flying again. The trust that allowed 4 human beings to climb into Orion integrity and travel 252,000 miles from Earth was the product of all of that work. Every test, every revision, every moment of saying, "This is not quite right. Let us understand it better before we proceed." It is a kind of faith, as the research notes suggest. Not religious faith, not faith in something beyond evidence, but human faith. Faith in the process of careful, iterative, honest scientific and engineering work. Faith in the laws of physics, which have never once changed their minds. Faith in the institution of human knowledge building, which is slow and imperfect and occasionally wrong, but which over time gets closer to the truth. The free return trajectory was not a hope. The heat shield was not a prayer. They were the products of that faith, made physical. The faith of 10,000 engineers, expressed in metal and polymer and mathematics. And 4 people trusted it with their lives. And it brought them home. There is one more thing that happened during the 10 days of Artemis 2 that we have not yet spoken about. Something small, something that could easily be overlooked in the accounting of records and firsts and scientific achievements. Before the crew left Earth, they were asked, as crews often are, about the experience of being in space and what they hope to find there, or bring back from it. Jeremy Hansen, the Canadian astronaut making his first spaceflight ever, said something worth sitting with. He said that he had spent years training, years preparing, years imagining what it would be like. And one of the things he had thought about most was this: what it would feel like to look at Earth from the outside. Not from the International Space Station, where Earth fills much of the view below you and remains overwhelming in its presence, but from far enough away that it is simply a thing in space, a beautiful, fragile, unmistakably singular thing, surrounded by darkness. He had imagined it. He had studied photographs of it. He had spoken to astronauts who had been to the space station and to those rare few who had been to the moon. He had built, in his mind, an expectation of what seeing Earth from 250,000 miles away would feel like. And then, he was there, and it was different from the expectation. Not worse, not less. Different in the way that real things are always different from imagined things, more textured, more present, more specific. The photographs cannot convey the quality of the light. The reports of other astronauts cannot convey what it is like for your particular eyes to see it, for your particular nervous system to receive that image and know that it is real, that you are actually here, that the distance is actual, not simulated. There is a kind of knowing that only experience provides. Photographs of the lunar far side exist, images of extraordinary quality, scientifically precise, visually spectacular. And 28 human beings have looked at it with their own eyes. Photographs of Earth from 250,000 miles away exist, and a small number of people have been there to see it directly. Jeremy Hansen was one of them, on his first day in space. The world he had spent 39 years living on, the gravity he had always known, the sky he had always looked up at, suddenly reduced to a circle, a single, finite, comprehensible object, the whole of human history, compressed into something that light takes 40 milliseconds to cross. He had imagined it. And then he was there. And it was different. That difference, the gap between the imagined and the actual, is one of the things that makes exploration matter. Not just for the science, not just for the records, not just for the engineering validation and the biological data and the geological observations, but because the actual is irreducible. Because there is something in the direct experience of the universe that photographs and descriptions and even the most eloquent narration cannot fully convey. We can carry you with us tonight, in imagination, through the arc of this journey. We can describe the heat shield and the free return trajectory and the 40 minutes of silence behind the moon and the crater named Carroll. We can offer every fact and figure and analogy and poetic observation that the mission provides. But we cannot give you the view from the window of Orion integrity at 252,000 miles from Earth. We cannot give you the quality of the silence in deep space. We cannot give you what Jeremy Hansen felt when he looked at the Earth, his first time, his real first time, and found that it was different from the imagining. That is why they went. That is why they will go again. Because the actual is irreplaceable. Because 28 eyes are not enough. Because the universe is patient, and the doors are open, and the knowledge is accumulating. And because quietly, something in the human being wants to know, not just to know about, to know. If you have traveled this far tonight, through the 54 years of waiting, through the launch and the coasting and the sphere of lunar influence and the 7 hours at the moon's edge and the silence behind it and the fire of coming home, we are glad you are here. This kind of slow, unhurried journey through something vast is what this channel exists to offer. If it feels worth returning to, you can subscribe. It costs nothing, and it means more nights like this one will find their way to you. The comments below are always a gentle place if you feel like leaving a word about where you are tonight, or what stayed with you from this story. Let us begin to slow now. The way a long journey slows as it nears its end, not abruptly, not dramatically, but with the gradual easing of pace that signals something is completing. The way music resolves toward its final notes. The way a long breath releases. The mission is over. The crew is home. The data is being analyzed. The engineers are refining their models. The crater named Carroll is on the moon. And the universe continues, exactly as it was. The moon is still there tonight. It is, depending on where you are and what the sky is doing above you, either visible or hidden by clouds. But it is there. It always is. At its average distance of 238,855 miles from Earth, moving in its slightly elliptical orbit, showing its familiar face to the night side of the planet, keeping its far side private. 4 people have recently been closer to it than any human being in 54 years. They looked at its far side. They named craters. They watched Earth disappear behind its rim and reappear again. They experienced, for 40 minutes, the most complete silence and isolation any human being has ever known. And they came back and said, "We are ready for what comes next." There's a question worth sitting with quietly as this journey draws to its close. What does it mean that we are the kind of creature that does this? Not whether it is wise or practical or cost-effective. Not whether the money might be better spent on other things. Those are real and legitimate questions, and they have real and legitimate answers that deserve their own conversations. But set them aside for a moment. Set aside every question except this one. What does it mean that we are the kind of creature that does this? That we look at a world 250,000 miles away, separated from us by 250,000 miles of vacuum and radiation and silence. And we say, we should go there. And then we spend decades building the means to go. And then we go, in a capsule the size of a camper van, with freeze-dried food and a broken toilet and an 8-year-old boy's mascot and a love letter pressed into the surface of another world. The universe did not require this of us. The laws of physics do not include a provision stating that one species on one small planet, in one spiral arm of one ordinary galaxy, must eventually leave the atmosphere of its home world and travel to the nearest other world. There is no cosmic obligation. The universe would continue perfectly well, continues in fact, for billions of light years in every direction. Without any of this, we did it anyway. We do it because something in us asks questions, because the distance between what we know and what we could know is, for some people and for our species collectively, a kind of discomfort that only motion can address. Because the horizon is always interesting. Because the moon, for as long as human beings have had eyes to see it, has been something other than simply the large, bright object in the night sky. It has been a destination. For most of human history, it was an unreachable one, a destination in imagination and myth and story, in the dreams that every culture has placed in that silver disk above them. And then, in a handful of years in the second half of the 20th century, it became reachable, and 12 people walked on it. And then it became, again, unreachable, not physically, but practically, in the way that things we have not yet decided to do are unreachable. And then, on April 1st, 2026, 4 people went back. Not all the way to the surface, not yet, but back into its neighborhood. Back into the silence and the far side and the gravity embrace of the free return trajectory. Back to the place where you can watch Earth set below a gray horizon and feel, in your body and your mind simultaneously, what it means to be somewhere that is not home. Victor Glover said it from 250,000 miles away, and it reached us. We are the same thing, and we've got to get through this together. Christina Koch said about the broken toilet in the campervan-sized capsule on its way to the moon, "We can't explore deeper unless we are doing a few things that are inconvenient." Jeremy Hansen, on his first day in space, which was also his first day in the moon's neighborhood, looked out the window at a world he had spent 39 years on and saw it, for the first time, whole. Reed Wiseman, 50 years old, the oldest human being ever to travel beyond low Earth orbit, asked Mission Control for permission to name a crater after his wife. Permission granted. These are not footnotes to the science. They are the science, in its broadest sense. They are the data that this particular kind of investigation, the investigation of what it means to be human in the universe, generates and gathers and carries home. The moon will be there tomorrow, and next year, and in 1,000 years, doing what it has always done. Orbiting, pulling the tides, keeping its far side turned away from us, patient and ancient and indifferent. And in 2028, if all goes as planned, human boots will press into the surface of the lunar South Pole for the first time in history. the first time anywhere on the moon in more than 50 years. And the people who make that step will carry with them everything that Artemis 2 taught. Every data point, every observation, every unexpected helium leak, every organ chip result, every photograph of Reiner Gamma, every correction to every model. And they will stand on another world and look up at the Earth and feel the particular shift that comes from being somewhere else, looking back. And eventually, in years or decades, by a timeline that is not yet fixed, human beings will make the much longer journey. The 7 months through the deep dark toward a red point of light that grows slowly into a disk, and then into a world, and then into the ground beneath their feet. Mars, the next destination in the chain that Artemis 2 is part of. The knowledge begins here, and perhaps it begins even further back than here. Perhaps it begins with the first human being who looked at the moon and felt, in some pre-linguistic way, the pull of it. Who was curious, who asked, in whatever form the question took before language, what is that, and can I reach it? We are the continuation of that question. Every astronaut who has ever left Earth's atmosphere is the continuation of that question. Every engineer who has ever calculated a trajectory, or designed a heat shield, or tested a life support system, is the continuation of that question. Every person who watched the launch from a beach in Florida, or from a live stream on a phone, or who heard about it in passing and felt something, a small quiet something, is the continuation of that question. You are the continuation of that question. Tonight, in whatever room or bed or corner of the world you are in, you spent time with this story. You traveled in imagination through the 54-year silence and the free return trajectory and the 40 minutes of absolute isolation and the fire of coming home. You held the image of Carroll, a name pressed into the moon across 250,000 miles of love. That is not a small thing. The curiosity that brought you here tonight, that made you want to understand what happened, what it meant, what the science was, what the people carried with them. That curiosity is the same curiosity that puts human beings in capsules and sends them toward the nearest other world. It is the same question, asked at different scales. What is out there? Can I reach it? What will I find? The answer for now is this. The moon waited 54 years, and when humans went back, they went as integrity. And they broke every record that had stood since the Apollo era. They looked at the far side with 28 pairs of eyes. They watched Earth set below a gray horizon and come back up again. They named a crater for love, and they came home and said, "We are the same thing, and we are ready for what comes next." That is more than enough to carry with you tonight. There is so much that remains unknown. Reiner Gamma's mystery is not solved. The full biological effects of deep space radiation are still being measured. The moon's water ice at the South Pole has not yet been touched by human hands. The path to Mars is mapped in intention, but not yet in footprints. And that is not a source of anxiety. It is a source of something quieter and more sustaining. It means there is more to understand, more to discover, more to feel when the discovery arrives. The incompleteness of knowledge is not a failure. It is the shape of an ongoing conversation between the human species and the universe it finds itself in. We are still early in that conversation. The universe is very old, 13.8 billion years, give or take, since the event that began everything. The Earth is 4.5 billion years old. The Moon is nearly as old. Complex life on Earth has existed for roughly 500 million years. Human beings, in something like our current form, have been here for perhaps 300,000 years. The industrial age is 250 years old. The space age is less than 70. We are, in cosmic terms, extraordinarily new. We are new, and we are already asking the questions, already building the tools to answer them. Already going back, the universe has billions of years left before the last stars go out. There is time. There is so much time for this conversation to continue, to deepen, to reach places we cannot yet imagine. Tonight, it has reached the moon, and 4 people have come home. Somewhere tonight, they are sleeping in beds that have gravity. Their bodies are relearning the weight of themselves. Their vestibular systems are settling back into the familiar orientation of a world that has a clear up and a clear down. They are perhaps dreaming of something, of the view from the window, of the earth setting below a gray horizon, of the silence behind the moon, of the music they chose for the journey home. Run to the water, free. The crater named Carroll is on the moon, sitting in the gray dust, exactly where it has always been. Now carrying a name it will carry as long as the moon exists, which is a very long time. Longer than any of us can meaningfully imagine. Longer than human civilization, longer than the human species, longer perhaps than the sun will remain the kind of star it currently is. A name, placed there by love, from 250,000 miles away. The universe does not know the name, the moon does not know it. But we do. And that is the quiet miracle at the center of all of this. Not the technology, remarkable as it is. Not the records, significant as they are. Not even the science, essential as it will prove to be. The quiet miracle is this. We are the part of the universe that knows. We are the part that crosses the distance and looks back and names what it sees. We are the part that says, this matters, this person mattered. This word, Carroll, integrity, rise, means something. And I will carry it with me to the farthest place I have ever been, and I will leave it there. In a universe that does not notice, we notice. In a universe that does not name, we name. In a universe that does not love, we love, and we carry that love 252,000 miles from home. And we ask mission control for permission, and we press it into the surface of the nearest other world. That is what Artemis 2 was. Not just a test flight, not just a mission, not just the first crewed lunar journey in 54 years. It was the latest iteration of a very old, very human act. The act of going somewhere and saying, we were here, we looked, we carried what we loved, we named what we found, and we came home and said, we are ready for what comes next. Rest now. The moon is where it always is tonight. The stars are where they have always been. The Pacific Ocean is calm off the coast of San Diego, and somewhere in that water, the capsule named Integrity floated for a few hours before being lifted aboard a ship and carried to shore. The journey is complete, and somewhere in the gray dust of the moon, in a crater that has sat unchanged for billions of years, there is a name, Carroll. That is more than enough to carry into sleep. This has been the Quiet Laboratory. We are glad you were here tonight. If something in this journey has been worth resting with, a thought you want to hold, a question you want to let sit quietly at the edge of sleep, the comments below are always open, and there is never any hurry to leave them. This channel will be here when you return. There will always be more journeys waiting. Sleep well.